Today's lesson is supposed to be about more sorts of difficult questions. So what I really want us to do is be able to end off with a sort of question that you would get in a matric exam paper. And I want to be able to go through some stuff that would help you to be able to access something like that. When you are in grade 11, the questions on quadratic number patterns carry far more marks than they would do in your grade 12 papers. So, when we're doing the grade 12 work, you'll see that there are far fewer questions. Maybe 2 of them are easy and then 1 is really difficult. Whereas if you're doing grade 11 work, maybe the first 3 are really easy and then only the second 2 are difficult, whatever the case is. So I think what I'm going to do is I'm actually going to jump ahead to this question. We can always come back to one of the others because I want to go through this concept of what is a minimum and what is a maximum, because it's not just important here in number patterns, it's also important in functions as well. Okay, so if we have a look at this question, it tells us that there is a quadratic pattern and it has a constant second difference of 2. It also tells us that term 5 is the same as term 17, and both term 5 and term 17 have a value of 29. The first question that they ask us is, does this pattern have a minimum or a maximum value? Justify your answer. Is there anyone of us that's here this evening that knows straight away how you would answer this question? If you can put your hand up, or if you can just give me a thumbs up if you know exactly how to answer this question. I'm going to give you guys a minute.
Let's go, my babes. Let's see. Let's go, my people. Let's show Teacher Lay what we know and what we don't know.
If you know straight away how you'd answer this.
Of Offense, I'll definitely just talk to Offense directly.
Thank you. Okay, so Offense can't hear anything. Can everybody else? Well, I know Yolanda, you can hear me. So I'm taking it by the fact that there is no thumbs ups at the moment, that no one is really sure about how we would go about answering this question. And I'm really glad to hear that, because this is something that I want to discuss with you. You have to be able to link the idea, and I hope your teachers at school have done this with you, but I hope that they have linked together. That's fine, Pinga. I'm glad. Then at least we're doing something that's fresh and new and hopefully a challenge for you guys. I hope your teachers at school have linked together the idea behind a quadratic number pattern and a quadratic function, the parabola. So when we talk about quadratic number patterns, we're talking about Tn, so the value of the particular term, equals an squared plus bn. Come on, pen, bn plus c. Right? When we are talking about the parabola, we are talking about y equals ax squared plus bx plus c. Can you see that these are actually identical? So a quadratic number pattern and a parabola have the exact same formula, right? The difference is this, okay? When we are talking about number patterns, there is a restriction on what n can be. So we can only have the first term of the pattern, or the second term of the pattern, or the third term of the pattern. Whereas when we're talking about a parabola, there's no restriction on what x can be unless we set one. So x can be a negative number or it can be a positive number. So if I now go ahead and I now draw a quadratic number pattern, right, it's going to look the same as a parabola. So in other words, it can either be a smiley face or it can be a sad face. All right. So if it is a smiley face, then this over here is what is referred to as its minimum. If it has a happy face, then that over there is what is referred to as the maximum. So if I say to you, what is the maximum of, and I give you a parabola, I'm asking you for the biggest number that that rule can generate. Okay, so if I'm asking you for a minimum, then I'm asking you, what is the smallest number that it can generate? So in other words, here in this quadratic number pattern, there is going to be a number that could either be a minimum or a maximum based on the shape. Okay, because graphs that have a smiley face have got a minimum, those that have a sad face have a maximum. So they're asking us, does it have a minimum or a maximum? Because this is based on shape, this goes back to the sign of this letter over here. All right, so if we've got something like y equals minus x squared plus 3x minus 4, then we know that this is sad face. Why? Because the coefficient of the x squared term is negative. That's what gives this a sad face. If I have another pattern or another parabola and it's y equals 3x squared plus 28x plus 101, then because 3 is positive, I know that my resulting parabola is going to have a smiley face. Do you recall this from grade 11? Is this making sense to you? So, no, Pinga, that is when you are talking about the range. Yeah, I suppose it is, because it would be y is smaller than this or y is bigger than that. You're on the right track. Yes, absolutely. Okay, so in other words, the sign of the x squared term depends on whether there is a maximum or a minimum. If it's negative, there's a maximum. If it's positive, there's a minimum. It's exactly the same thing with quadratic number patterns. If the number in front of the n squared is negative, then your pattern will have a maximum value. If the sign of a in front of the n squared is a positive, then your pattern will have a minimum value. Okay, so I'm trying to link it to what you already know about the parabola. So now, essentially, what this question is asking us to do is they're asking us to work out the value of a, as in this a over here, the a of Tn equals an squared. And if it's positive, then the pattern is going to have a minimum. If it's negative, the pattern is going to have a maximum. So they tell us that the constant second difference is 2. What does that mean for us in terms of a? What can I do with that 2? The constant second difference is 2. So what does that mean? How do we find A and B and C? Exactly, perfect, brilliant. Okay, so what we are doing here is we are taking 2A and we are making it equal to 2. Wonderful. All right, and then what that means is that A is equal to positive 1. So A is positive. So therefore this pattern has a if it's positive, A has a minimum. Okay, does that make sense to everybody? Well done. Okay, so a mark for that, a mark for that, and a mark for that. Yes. No, we're actually still on the first question, Amina. I jumped forward because this is something that is really important that I wanted to discuss with you. Okay, how are you feeling about this idea behind a maximum and a minimum, grade 12s? Thumbs up or thumbs down? Is this making sense? you.
Or you can raise your hand and just explain to us. Do you understand? Nice, guys. Well done.
So Letu, you happy? Thank you. How about the rest of you? Thumbs up or thumbs down for 4.2.1. Please don't be afraid to say you don't understand. Fine, Nazuli. Somewhat understand. Okay.
I think there was a question there.
I think there was. Okay. Bonga, I'll go over that again with you. Okay. So Lorato, no problem. All right, Kelebohile, fair enough. You've missed. Okay. So I'm just going to go through this one more time because questions about minima and maxima do come up a lot in matric. So understanding what a minimum or a maximum is actually a very important concept for you. Okay. So what I'm trying to do is I'm trying to link your understanding of quadratic number patterns to what you know about the parabola, because a parabola and a quadratic number pattern have the same formula. The difference is that we refer to y in our parabola. Y is our output. That's what Tn is in the number pattern. Okay, so in other words, the value of the term. So y is our output. We're talking about number patterns. It's the value of our term. When we're talking about number patterns, n is our position number in the pattern. All right, that's the same as x is in the parabola. That is our input. Okay, so when we talk about a parabola, we know that a parabola can be either this shape over here, or it can be that shape over there. Okay, so we refer to this, we're going to have different names for this in matric, but we basically refer to this as a sad face parabola, and we refer to that one as a happy face parabola. Okay, so when it comes to a parabola is a rule that takes in numbers and generates other numbers. So the numbers that go in are the x's, and the number that it generates are the y's. Okay, so if a pattern, okay, makes this sort of shape, it's going to generate a maximum value. And if a parabola is this shape, if it's happy faced, it's going to generate a minimum value. Your maximum and your minimum are your y values. Okay, they are your outputs. Okay, so when a particular x goes in, you get a particular y value out. Okay, so when whatever it is goes in, you get a maximum of whatever it might be. Or when x goes in over here, you get a minimum of whatever that might be. Okay, so it is exactly the same with quadratic number patterns, right? They can also have minimums or maximums based on their shape. So let's consider this very carefully. How is shape affected? What letter affects the shape of a parabola? It's the letter A. A is what affects the shape of the parabola. So if there is a negative in front of the x squared, so I'm going to make up an example here. So if we've got y equals negative 2x squared plus 3x, then this particular pattern, all right, is going to have a sad face because of this negative 2 over here. If I have a parabola and it is y equals x squared plus 3x plus 10, all right, it is going to be a happy face parabola because in front of the x squared, the invisible number that's sitting there is a positive 1. Right. So it is the value of A that affects the shape of the pattern. It is the value of A that affects the shape of the pattern. So here they tell us that this pattern has a constant difference of 2. That directly relates to A, doesn't it? Because 2A is equal to 2. So this tells us something about the A in this pattern. A is equal to +1. So because it is equal to +1, this pattern would make a happy face, except obviously we wouldn't consider those unnatural numbers over there. We would only consider the counting numbers on this side, which means that it has to have a minimum and not a maximum. Okay, that's what I was trying to get at. Okay, it has to have a minimum. Okay, because A is positive. All right, so the marks here would be allocated to you knowing that constant difference of 2 means 2A equals 2, solving for A, and then based on the sign of A, deciding whether the pattern would have a minimum or a max. Okay, we then go on to the next question, 4.2.2, where they ask us to determine the nth term in the form Tn equals an squared plus bn plus c. So if A is positive, the graph has a minimum. Yes, Shane. And if A is negative, the graph has a maximum, or the pattern has a maximum. No, absolutely not. Isn't that interesting, Watobe? Because we have to, so not only when they give us a question, we have to pick out when we're answering a particular question, what bits of the information that's been given to us is relevant to that particular question. So yes, we are not looking at T5 equals T17 equals 29 to answer question 4.2.1. We only need the first bit. And this is why your theory is so important. Okay, you have to study the theory and know the rules, because without that, you're not going to know which bits of information are important to be able to answer which questions. Okay, so you've got to keep practicing this. Now, Watobe, in order to determine the nth term for the expression, now T5 equals term 17 equals 29 becomes important. Okay, but we have a part of the puzzle already. Okay, if they want us to determine the nth term of the expression, they want us to give the answers of A and B and C. We already know what A is. We know that A is equal to 1. Okay, now here they tell us that term 5 and term 17 both have the same value of 29. How is that possible? How is it possible that term 5 and term 17 both have a value? Think about the parabola. Think about what you know from the parabola from grade 11. So with all parabolas, they are arches, aren't they? So as far as this particular pattern is concerned, right, if I was to draw, and I'm not obviously 100% sure of where it would be, okay, if that is your set of X and Y, whoopsie, X and Y axes. Okay. If your parabola was, and we don't know, okay, so it's got a minimum. We don't know what the minimum is though. Okay, so I'm going to draw this, but I'm not 100% sure of where its position is. I just know what its shape is. Okay, so I know that it has to have a minimum value. All right. So if I say that over here is 1, and then there's 2, 3, 4, 5 would be somewhere over here. Then when I get here, I've got the same value in terms of Y again. So if I read off over there, I'm going to end up with 29. So when 5 goes in, I get 29 out. And when 17 goes in, I also get 29 out. That's what it means. Does that make sense now that I'm drawing a picture for you? Oh, a smiley face or sad face, everybody? How are we feeling?
It votes. How are you guys feeling? Is it okay? You want more explanation? Please don't be shy, because this is important for us to understand. So you can just indicate on the chat, or you can use emojis so that we can sense on how you feel about the explanation so far.
Right. I personally think that when we draw pictures like the one that I've drawn you over here, to me, this is what makes the most amount of sense. Okay, so that I can understand why it is that both term 5 and term 17 can have the same. So this is your TN over here, and this is your N over there. Okay, so when 5 goes in, we get 29 out. When 17 goes in, we also get 29 out because of the shape of the number pattern, because it is quadratic. So essentially, we already know what A is. We know that A is equal to 1. So this question is asking us to work out the values of B and C. That's what they want from us. So if they want us to work out the values of B and C, how do we work out, what method do we use in maths when we want to solve for 2 different letters at the same time? What method do we use? Yes, Pinga. Correct. So 5 and 17 are your positions. There we go, offense. Quite right. And 29 is your output. There we go. So simultaneous equations. Exactly. Exactly. So now, not only do we need to be able to say, what information have we got? All right. What information do we still need to calculate? But how are we going to calculate that information? Brilliant. So you've all said we need to solve for B and C simultaneously. So that means we need to make 2 equations from the information that has been given to us. Okay, and we're going to solve for B and C simultaneously. So I'm going to make the first equation, and you, or mind you, actually, maybe, no, not like that, Ofense, not like that. Okay, because we do not know any more about the number pattern. Remember, we don't know the quadratic number pattern. We don't know its first, second, third terms. We don't know its first differences. All we know is what its second difference is. So the only way that you can do this, and somebody else said this over here, is by substitution. I don't know who it was. Let me just go up here, have a look. Someone said substitution. Yes, so Shane, we're going to use substitution, and Bonga, Sashana, Chloe, everybody else, we're going to solve simultaneously. Remember, 29 represents our Tn. So if we are subbing into Tn equals An squared plus Bn plus C, we already know that A is equal to 1. We know that Tn is equal to 29. We know that A was equal to 1 when 5 goes in. So B times 5 plus C. So here I'm making equation number 1. Can everybody see that? So when N is equal to 5, Tn is equal to 29, and I have subbed in that A is equal to 1. So this gives us 29 equals 25 plus 5B plus C, which means that 4 equals 5B plus C. That is equation number 1. Okay. We don't have to equate the equations. We have to solve them simultaneously. Yes, Phoebe, quite right. Okay, so where to? I am subbing in the information that I have been given. Remember, Tn is like your Y, that is your output. Okay, so Tn is like your Y, that is your output. That's why I'm putting 29 over here. 5 is like your input. That's why I'm putting 5 over here in place of N, and 5 over here in place of N. And I'm developing an equation in terms of B and C because those are the 2 letters that I want to solve for. But I need a second equation. Okay, I need to make a second equation. So what's the second equation Okay, good stuff. Yes, absolutely. You have to, Londeka. You have to. That's how you're going to get the second equation. So tell you what, you guys make that second equation. Just challenge yourself, see if you can make that second equation. I'm going to make it with you as well and check that you're right, but see if you can make that second equation by working with the 17 and the 29. So I'm going to give you 2 minutes to do that. Hopefully you're okay with that. Yes, so Masejo, remember when n is equal to 5, so the fifth term in the pattern is 29. Okay, so I'm substituting n, I'm substituting 5 for n and 29 for tn. Okay, because they told me up here that term 5 is 29. Okay, so when 5 goes in, position number 5, 29 comes out. Okay, or in terms of number patterns, the fifth term of the pattern is 29. So Shane, I get the same as you. Buhle, I didn't get that. Yes, Shana, I got the same thing. Pagelo, I got the same thing. Mpilenhle, beautiful. That's exactly what you would have needed to do. And then you would have simplified it and you should have got what Shane, Sashana, Pagelo got. Okay, Mispa, I'm not sure where that went wrong, but I'm going to do it on the board quickly now anyway. Yes, it's okay. Mispa, don't stress. You must know how many mistakes I make in a day. Okay. So quite right, lovely guys, I get exactly the same thing. So if I just do it here on the side in a different color, we would end up with 29 equals 1 times 17 squared plus b times 17 plus c. So this gives us 29 equals 289. Plus 17b plus c, and then if we take that 289 over to the other side, we get minus 260 equals 17b plus c, and that, ladies and gents, is our second equation. So now we have two equations in terms of b and c. Okay, that I've now highlighted in turquoise for us. We now need to solve those simultaneously. All right, so I'm just going to get rid of this over here. Okay, and I'm going to bring these two equations up to the top. All right. All right, so here we go. We've got 4 equals 5b plus c, and we've got minus 260 equals 17b plus c. So now, when you can, with absolute pleasure, are we going to use the elimination? Offense, you certainly can do. Both of you are correct. I personally prefer elimination over substitution because I think it's quicker and easier, but you do whatever you feel comfortable with. If you would prefer to make C the subject, go right ahead. If you did that, what I would do is I'd probably work with the first equation and make C equal to 4 minus 5b. That means you can then sub into minus 260 equals 17b plus 4 minus 5b, and you can solve for b that way. Or you can solve by elimination. So what I would do here, because we want to eliminate the C's, I think it was Offense you were asking me. Let me just go back and have a look. No, yes, it was Offense. So Offense, if you want to do it by elimination, we can do that. So we can say 4 minus negative 260, so that would give us 264. 5b minus 17b, that would give us, oh, I'm just being silly, 5 minus 17 would give us negative 12b. And then obviously our c's would be eliminated. So now we could divide both sides by negative 12. And that means that b is equal to negative 22. You should have got the same answer this side as well. Okay, so here we would have ended up with 12b minus 264, divide both sides by 12, and b would have been negative 22. Okay, so this method over here is the elimination method. Phoebe, I'm going to take your question right now. This method over here is substitution method. Okay, Phoebe, go for it. You're welcome to unmute and ask. Sorry, Phoebe, I can't hear you.
Ma'am, I was going to ask if you can make a third equation, but then I understand that you're still doing elimination.
Yes, yes. So if you wanted to make the third equation, this would have been equation number 3 over here when you made C the subject of the formula. Of course, if you wanted to work with equation 2 and make C the subject of the formula and sub into equation 1, that's also okay. All right. You keep getting 21.3. I will explain the elimination method again, Nico, no problem. Shane, what I'm going to do is, Yolanda, could you just maybe help Shane and just find out why they're getting 21.3?
Perfect. I'm sending you a direct message, Shane.
Okay, thank you so much. Okay, so when we eliminate, I love the elimination method, and I actually think it's very useful in matric as well. You can only do it when you've got 2 linear equations. And the idea is you have to pick a term to eliminate. So because we've got plus 1c over here and we've got plus 1c over here, all right, the c term is the good one to eliminate, okay, because the coefficients are the same. When the coefficients are the same, we can eliminate, so we can either eliminate by adding or by subtracting. So essentially what you're doing is you're working in columns. So you're saying 4 minus negative 264 and getting 264. Then you're working in the B column here. So 5b minus 17b is 12b, and positive c minus c is 0. That's elimination. The c has been eliminated. Does that make sense, Nico? All right, and now that we've got B, we're ready to find C. Okay, and that we obviously have to do by substitution. So I'm going to use the first equation. 4 is equal to 5. B is negative 22 plus C. So that means this is going to be 4 plus 22 times 5 is 110 is C. So that means that C was equal to 114. Is that what you guys are getting as well? Where, Kevin? Oh, hang on. No, it's positive 4, Kevin. It's positive 4. Remember, it's from this equation over here. Okay, so it was 29 minus 25, which is positive 4. Okay, so this is a positive 4. Okay. Oh, cool. All right, there we go. Okay, so here is simultaneous equations, the solving of simultaneous equations creeping into this. Okay, so it was what n squared minus 22n plus 114. All right, and now we've dotted the i's and crossed the t's, so to speak. We've determined the expression of the nth term. Okay, how does that feel? How do you guys feel? You feeling thumbs up or thumbs down? Is it making sense? You feeling good? Yes. Yeah, that's fine. Go and rewatch the video if you need to, Amina. I think seeing it all the way from the very beginning, it'll probably make a bit more sense than you sort of jumping in halfway. Okay, good. All right. So I'm really pleased about this because, as I said to you, the whole idea behind maximum and minimum is really important. We've got to be able to do this. Okay, iPhone, we actually need your name. How got C? Remember when we're solving simultaneously, we take our one answer and we sub it back into one of the equations. So what I did here is I used this first equation. See, I've got 4. So I'm working down here at the bottom. So 4 equals 5b plus c. That was this equation over here. So now that I know what b is, I'm subbing back into either one of my 2 equations. Okay. All right, lovely. Okay, good stuff. I think 4.1 is a nice difficult question for us to try. What I'm going to do though is let's see if we can come back to 4.1 and 4.2. That's fine. I'll leave that over there. What I wanted to do was actually show you this question over here. All right, because this came out of an NSC exam, all right, and it was the June NSC exam from last year. So in other words, this was the supplementary paper that was written. But you know, the supplementary papers are just as challenging as the end of year papers. So I found this question online and I just wanted to show you the sort of thing that you would see in matric. Okay, quadratic number patterns are not a huge number of marks out of the whole paper like they are in grade 11, okay, because you've got new work. So essentially here, the quadratic number patterns section in this matric paper came to a total of 9, right? If we can get this question right and this question right, that gives us 5 out of 9, which roughly translates to 55% for this particular question. So if we want 100% for this question, we need to be able to access all 4 of those marks, or at least some of them. Can you see here again, is this word maximum creeping in? Okay, so that's why I just wanted to bring it up with you. But there's a bit of a twist in the tail here. It's not a straightforward question at all. And this is what we need to look at. So what I want to do is I'd like to give you 5 minutes, right? You do question 221 and 222, straightforward. And then we're going to talk about how we should answer 223. Okay, all right, so ready, steady, go. You've got 5 minutes.
Woo, we can do this. 5 marks, guys. Let's go. I'm sure this will be a smooth one. Smooth 5 marks for this class. Yeah.
Okay, so you've got 3 minutes, guys. Three minutes. Good, Kevin. Yes. Okay, now 2, 2, 2, please. Okay, so Shane, they are asking you for the nth term. Okay, so what they've done in this particular question, holding my pen the wrong way around. How silly am I? Okay, they are asking you for Tn equals an squared plus bn plus c. So this is, as we have practiced in our last lesson, how we would find values of a, b, and c. So remember, we've got to use the rules. 2a equals our constant difference. 3a plus b equals the first term of our first differences. And a plus b plus c equals the first term in our quadratic pattern. Okay. Okay, so no problem, Shane. Where to? If you are not getting the first question, so writing down the value of the fifth term, you've got to work out by how much the pattern is decreasing. Okay, so if they've given you, everybody else just ignore me and continue to work, unless of course you're struggling with this as well, but if you're busy with 2, 2, 2, just ignore me. So you've got 75, you've got 53, you've got 35, you've got 21. So now you've got to work out your first difference, term 2 minus term 1. So 53 minus 75 is negative 22. 35 minus 53 is negative 18. 21 minus 35 is negative 14. Okay, so now what do you need to have in this block over here? What needs to go inside this red block to work out what the fifth term is? Okay, all right, you guys are flying. Well done. Brilliant, brilliant, brilliant. Okay, excellent. Nice. All right, so I get exactly the same answer as you. Sorry, my cool drink went down the wrong way. Okay, so in 222, using these rules, I also get Tn equals 2n squared. Then I got minus 28n plus 101. Do we all agree? That's it. Well done. Okay. And now you can see how quickly you guys have been able to do that now that you've been practicing. And that's why I keep saying to you, keep practicing your work. You've got to stay up to date, because when you practice things, they become easier. It sticks in your mind. It just helps to solidify and complement, solidify the ideas in your head. Okay, so now in the last few minutes, they ask us to then determine the maximum value of the following number pattern. Well, clearly, if this is question 223, question 223 has to be linked back to that. So how does this new pattern relate to the old pattern? Compare the first term of the old pattern with the first term of the new pattern. How would 75 become negative 15? What would I do to negative 75 to make it? Do we find the constant difference? No, Boitumelo. So we're making a comparison. Compare the first term of the old pattern with the first term of the new pattern. Compare the second term of the old pattern with the second term of the new pattern. What are we doing? I think you guys have cottoned on to it now. Aha. So that's it, Shane. All right, we're dividing by negative 5, not just 5, but negative 5. Would you be, Yolanda, would you be able to help Kakleho, please? Thank you.
On it.
Thank you, my darling. Okay, so we are dividing by -5, right? So now, how does that affect what we have in 2.2.2? If our answers have been divided by -5, what am I doing to my nth term? So in other words, what I'm saying to you is that in question 2.2.3, your nth term has changed because what you have done is you have taken Tn equals 2n squared minus 28n plus 101, and you have divided everything by -5. Absolutely, by -5, Penga. Okay, because remember, Tn is your result. It's the value of your term. So each term has been divided by -5 to yield the terms in the new pattern. So now what is our nth term going to be? Our nth term for this new pattern is now -2/5n squared. Negative divided by negative is a positive, plus 28n/5 plus 101/5. Oh, sorry, I'm talking nonsense. I've made a sign mistake there, haven't I? It should be a negative. Okay, so each term in my nth term has been divided by -5. Does that make sense to everybody? Thumbs up, thumbs down. Are we all good? We happy? We hanging on? Yolanda, if you can help, good. I'm so glad. I'm so glad. If you can help aware to, just because I want to finish this.
Okay, that's fine.
All right, that's fine. Okay, and now that we've got this new nth term, okay, what is the sign of A? A is negative. Okay, so because A is negative and this is a quadratic pattern, it has to have a, all together now, I hear you all yelling at home, it has to have a maximum. Okay, do you see how this ties together with what we've seen before? Okay, so if the number in front of the n squared, just like the number in front of the x squared, if it's a negative, the pattern has a maximum. Okay, is this making sense now? Now they're asking us, what is this maximum value? What is this maximum value? All right. Now, again, when we link this back to the parabola, right? When you want to find a maximum, let's say y equals minus x squared plus 3x minus 4. If I asked you how you would find your maximum in this case, there is a formula that is not given to you that you could use. Does any, fence? Beautiful. Nice. Okay, remember that formula, x equals minus b over 2a. But in this case, we're talking about n equals minus b over 2a. All right, so yes, you can use that. All right, beautiful. All right, up there, just hide that. Okay, so now I want you to sub into n equals negative b over 2a, and I want you to tell me what your n is. That's it. Okay, 100%. Okay, remember n has to be a natural number. Lovely. So we've got negative 28 over 5 divided by 2 times minus 2 over 5. Beautiful. And we get 7. What are we going to do with a 7? So the maximum, the maximum of this new pattern occurs at position 7. Okay, so what are we going to do with the 7 now, matrix? We're going to take it and we're going to... That's it, offense. Okay, good, lovely. All right, so what I'm going to do... That was just a different way of doing it. Quite right. I'm going to take... So to work out my maximum, which is my Tn, I'm now going to substitute it 2 over 5 times 7 squared plus 28 over 5 times 7 minus 101 over 5. And you tell me what you get as an answer, matrix. I didn't get that. Long. 3. You should be getting, yes, that's it. That's it. That's it. Yes, Amina. Yes, Misbah. Perfect. Perfect, perfect, perfect. Minus 3 over 5. Just be very careful when you pop that into the calculator. That's it. Mpilendle. Perfect. Maklong, yes. Good job. Okay, good, Amina. I'm so glad. And now you don't have 55%. Now you've got 100% for this question. Okay, so we can scratch out the 5. We can put 9 and we can change that to 100. Okay, and that's where we want to be in matric. We want to be able to do all the grade 11 work and get all the marks for it. Okay. That's it. Lemogang, perfect. All right, so tonight is quiz night. So Yolenda's going to pop the link to the quiz into the chat for you guys. Yeah, sure, Bongo, not a problem. Just scroll down. Here you go. Pleasure. Nizole, do you remember we're talking about the link between the parabola and the quadratic number pattern. So negative b over 2a allows us to find the n or the x at which the maximum or minimum occurs. So that is a formula that you would have been taught in grade 11 when you did the parabola in the form y equals ax squared plus bx plus c. So the exact value of the maximum, sorry, is this value over here. This is the answer. That's the maximum. So that is that's the output or the Tn when the n is 7. Okay. It doesn't have to be completed before tomorrow, but you know what? If you've got time now, rather just go and do it and get it over and done with. Okay. And then at least it's out of the way. It really shouldn't take you long. It should honestly be about 10 or 15 minutes and you should be done. Katleho, go for it. What question do you have?
Ma'am, I'm still stuck at 2.2, ma'am. I think I'm a little bit confused, ma'am, about how you get to like find what is the number of A and B,
Oh.
ma'am, because if it's the first term minus the second term or the second term minus the first term.
It's the second term minus the first term. So term 2 minus term 1, term 3 minus term 2. So that's what I was doing over here in red. 53 minus 75 is negative 22. 35 minus 53 is negative 18. And then what you would have worked out is that your constant difference was equal to 6. 4, sorry, 4. Beg your pardon, that would have been 4. So then what we would have done is we would have used these rules over here. So we would have said 2a is equal to 4. So therefore a is equal to 2. Then you would have subbed in here. 3 times 2 plus b would have been equal to negative 22. And then you would have worked out what b was. And then once you've got a and b, then you can work out what c is. Remember, a plus b plus c has to be equal to the first term of the quadratic pattern. So this would have to be equal to 75. Okay, so in this case, b is equal to negative 28.
Ma'am, that's the part that's like really got me confused, ma'am. I don't understand. Why is it negative 28, ma'am? Because 3 is positive.
So if you've got 3 times 2 plus b equals negative 22, 3 times 2 is 6, isn't it? Mbali, sorry, one second. Mbali, no. A quadratic pattern cannot have a constant first difference. If a pattern has a constant first difference, it can only be a linear pattern. All quadratic patterns have a first difference that's linear and a second difference that's constant. Okay, so my girl, if what we would do here is we leave the b this side, and now it would be minus 22 minus 6, isn't it? Because when this term goes over to that side, it becomes a negative, and that's why b would be equal to negative 28.
Oh, okay, ma'am. Thank you.
Okay, that's where this comes from over here. Okay, Katleho?
Yes, ma'am. Thank you, ma'am.